Okay, so this is a good problem for disk or shell. And now it comes from your homework from 7.2, which I think is the disk method section, but that doesn't matter because in the end you just want to be able to use both of them or really be able to pick which one is better for the particular problem. So first let's find our region. There's my line y equals x. Y equals 0 is the x-axis. Y equals 7 would be up here. And then x equals 8, sorry, that's x equals 7, x-axis, and then x equals 8 we'll call right here, and then so I got this weird like trapezoid to deal with, right? And not only that, is I'm rotating around this line. Okay, so if I do the shell method, I got a little problem. I got something I got to think about. Like I want to do my initial reaction is do the shell method because I know when I do the shell method, I work with functions of x, and they're just typically easier because we've done it our whole math careers. And if I can find the height of that as a function of x, and a distance from here to here as a function of x, I'm in good shape, right? Because the shell method is just 2 pi this distance times this distance. However, I got a problem. This height isn't going to be represented by, now obviously the distance is, the function of x is just x, right? So if I do the shell, I'm kind of building my shell method. I got 2 pi. I got the distance from here to here, I'm thinking is 8 minus x, and I'm thinking the height is x. And then I got a problem though, because this doesn't work when this, remember, this rectangle can be anywhere. So you could like draw it in a couple places and you can still ask yourself, is the height still x? Yep. Is the height still x? Yep. Is the height still x? And here the answer is no. The height's 7, right? If this is x at 7.5, the height's 7 because it levels off here based on our region. So we got a problem. We could use the shell method, but we'd have to do one integral, and then we'd have to do another integral, and that would just be this one, which would just give me a solid cylinder. So it wouldn't be terrible to do the shell method. We could figure that out. But I want to do this by the disk method because I think I can write a single function. So let's see if we can do it. So the disk method goes like this. I draw my triangle perpendicular to the line. Okay, and we don't have to worry, and we're going to rotate around here, so we don't have to worry about the washer. We don't have to worry about a little r because there is no hole when I rotate this guy around, right? So there won't be any hole in my three-dimensional volume. So I don't have to worry about that. So it's just going to be an r of y squared. It's going to look like this. I got to find my bounds from a to b, and then it's just an r of y squared. Okay. Now, why is it a function of y? Well, that's just how it works, right? You can remember if I'm going to go disk method, rotating around a vertical line, it's got to be a function of y. That's how we represent this, the distance from here to here. Okay, and we integrate over y. So if I know that that's how it works, and I know I'm going from 0 to 7, and now I just need to represent here to here as a function of y, and that shouldn't be too bad. As, and this, I always think this is tricky just because we're used to these ones are a lot easier. Let's say I did something like this. To me, this always is easier. I said, well, what's the distance from here to here as a function of x? And that's 2, and this is my function x squared. Well, the height of this rectangle, if I were doing the shell method, would be 2 minus, right, the difference from here to here, 2 minus x squared. And to me, that makes sense. We're just used to working with x's, right? So apply that here. Well, that's the same idea. If you just kind of flip this guy 90 degrees counterclockwise, it's the same idea as this, if this one makes more sense to you. So it would be 8, right? The distance from here to here is this x value, right? Input y, output x now. It's reversed. So it would be 8 minus what? This function of y. Well, what's the function of y? Well, here's my equation, y equals x, and sometimes you have to solve that for x, right? But in this case, it's already done. So this function of y is just y, because that's how it's given. If this were x equals y squared, then this would be y squared. Okay. Now, I guess you could ask yourself, well, what about this like extra thing here? Does that get in the way? Do I have to consider that? And the answer is no, because well, what's the distance from like here to here, right? Like somewhere in this region. Does this, if I put this rectangle like up here, right? I guess it would be that. That's the smallest rectangle I can have if I move it all the way up. What's the distance from here to here? Does it work? Well, it would be 8 minus the y value right here, which is 7, right? And that works because 8 minus 7 is 1, and the distance of this whole thing is 1, right? So that rectangle would work if you moved it all the way here. And then when you get past this point, like longer rectangles, it still works as it varies. It's variable. All right, so that's it for that one. And you could try that by the shell method and you get the same answer, right? The shell method, you'd have to do a function of x and another function of x and add them together. But this way will get you there a bit quicker.